Hello and welcome to 6-5. We're talking about vectors and dot products. A dot product given two vectors, it's kind of like a multiplication of two vectors. The way you solve for a dot product, and the answer will be a number, not a vector, that's very clear. The dot product of u and v, vectors u and v, is basically multiply the first two terms, u and v, and multiply the second two terms. So u1 and v1, and then u2 and v2. So first term and first term multiply, second term and second term multiply, and then add them together. Once again, the answer will be a number, not a vector. Dot product is important because what dot product tells us is it tells us how much two vectors are going in the same direction. So, some properties of dot products. I'm going to go through these quickly. You can pause the copy if you need to. Given u, v, and w being vectors in the plane, and c being a scalar, then the dot product of u with v is the same as v with u. The dot product of 0 with v is just simply 0. And the dot product of u with the sum of vectors v and w would be the dot product of u plus the dot product of w. Number 4 is a special one. It's the dot product of a vector with itself. It equals the magnitude of the vector squared. And finally, a scalar multiplied by a dot product is simply equal to either the scalar times the first term, and then you would do the dot product, or the second. When you multiply a scalar through a dot product situation, you do not multiply both of them by that scalar term, because if you do, when you multiply the terms together, it'll end up getting counted twice. So finding the dot product, find the dot product of each of these. So the dot product of vector 4, 5 with 2, 3. So that would be, the first two terms are 4 and 2. 4 times 2 is 8. Next two terms are 5 and 3. 5 times 3 is 15. Add them to get 23. First term times first term plus second term times second term. So the next one, 2 negative 1, 1 negative 2. 2 times 1 is 2. Negative 1 times 2 is negative 2. 2 minus 2 is 0. For the third one, 0 and 3. 0 times 4 is 0, and 3 times negative 2 is negative 6. 0 minus 6 is negative 6. Our dot product, remember, is a numerical answer. Using the properties of them. So let's say that we have vector u is negative 1, 3, vector v is 2, negative 4, and vector w is 1, negative 2. Find each dot product. So the dot product of u with v times vector w. Well, we can begin by finding the dot product of v and u. So v and u, negative 1 times 2 plus 3 times negative 4 gives you negative 14. Now I would take negative 14 and I would multiply that by vector w. When I multiply dot product times a vector, I'm going to end up getting a vector as my answer, because ultimately I've got that vector I have to deal with. Dot product may be a number, but a vector is still a vector. So negative 14 times 1 and negative 14 times negative 2 gives me vector negative 14, 28. On B, the dot product of u with twice of vector v. So I can take the dot product of u and v, which is negative 14, and multiply that by 2. Okay, you can just take that 2 out there. Remember, we can take the 2 out there because we're not doing it by u and v. So if I have a dot product given to me and I want to know what the magnitude is, well, because the magnitude of the vector squared is equal to the dot product, and the dot product is equal to 5 if you have the dot product of a vector with itself, then as a result you would have the square root of 5 as your answer. So because I was given a dot product of a vector with itself, then the magnitude of it would simply be the square root of that, the length of that vector. Now, finding an angle between two vectors. This will come in handy for your project. Let's say that you have an angle theta, and it's an angle between two vectors that are non-zero, vectors u and v. So then you can solve for the angle by saying the cosine of theta is equal to the dot product of vectors u and v divided by the product of their magnitudes. So I would take the dot product of the two and divide it by each of their magnitudes multiplied together. And then finally you would take the inverse cosine of it, because you have to take the inverse cosine to find theta. So let's say I've got a vector u at 4, 3 and vector v at 3, 5. I want to find the angle between them. So the dot product will be 4 times 3, which is 12, plus 5 times 3, which is 15, which gives me 27. The magnitude of u will be 4, 3 plus 3 squared, and take the square root of it, which is 5. And the magnitude of the second one will be 3 squared, which is 9, plus 5 squared, which is 25. The two of them together are 34, the square root of 34. So the cosine of theta will be equal to 27 over 5 times the square root of 34. In order to solve, I have to take the arc cosine of that, or the inverse cosine of that. When I take the inverse cosine of that amount, it is 22.2 degrees. The last definition we have is of an orthogonal vector. An orthogonal vector means two vectors. Vectors are perpendicular, okay, which is a 90-degree angle. So two vectors meet at a 90-degree angle, meaning that they're orthogonal if and only if their dot products are 0. So in the example, are these two dot products orthogonal, or are these two vectors orthogonal? I take their dot product, which will be 2 times 6 plus negative 3 times 4. 12 minus 12 is 0, so therefore they are orthogonal. And that concludes this lecture.